So today we actually start with a different concept of SQL, that is working with multiple tables. Okay. Till now we have been working in SQL, but we have been working it with single table only. So whatever query I was writing, whatever query I was doing, I was working with a single table always. Okay. Now sometimes what happens is that I need to extract data at a time from multiple tables. Fine. To understand the need, just see this particular example. There are two tables here. One is teacher, one is department. Okay. Here I see that the details of the teacher will be here. So teacher number, teacher name, which department it is working, the department number is there. Then other details are also there. The salary, the perks, maybe address, telephone number, etc. etc. Experience, date of joining, date of birth, everything I have it in this table. Okay. So for the teacher, it is a permanent kind of a table. Hence, my teacher code is my primary key. Fine. I have another table which is department because here I have picked up the department number. Okay, in the teacher table. So I have little more details about the department table, and for every department, I don't want to have the entire data put in the teacher table. Okay. So I have a department table separate where I have the department number, the name of the department, number of people working, maybe the location. Supposingly, some department sits in Gurgaon, some department sits in CP office, whatever. Okay, date of start, the manager ID, kuch department details. All those details are here. Fine. Now, if you remember the concept of primary key foreign key relation, then you can make out from here that department number is the primary key in the department table and teacher number is the primary key in the teacher table. Okay. I'm not preserving all the department details whenever I am storing one new teacher's data. Why? Because one department has, suppose, 50 people. Correct. Now, 50 people ka data I'm storing regarding one department, and 50 times, why should I store the department details also? Are you getting my point? I can just have one database, one table available with teacher details also, department details also, salary details also, everything in one table. But the problem is you will find that in that kind of a situation, the repetition of data is too much. Like I'm saying, this department table, let it have uh, 10 more fields which contains date of start of the department, location of the department, number of people working there, manager ID, who's managing the department, experience of the person who's the manager, something. Okay. So all these details you unnecessarily repeat 50 times whenever you are trying to put that department detail in the teacher table. Like Samit has joined department number 2. This department number 2 has got 50 people. Okay. Now for 50 people, whenever I'm going to store department number 2, if I am not maintaining the data separately, I would have to store it here. So 50 bar that data about all the departments, I mean about the department, the details about the department will be repeated. Once here, whenever the next person joins for D02, the data will again repeat. The whole data will repeat. Okay. That's called in database terms as redundancy. Data redundancy. Fine. We don't want that. We want to avoid data redundancy, and hence we go for dividing the data in such a manner which reduces the data redundancy, yet I'm able to extract the information whenever required. And this kind of a setup in database terms is called as normalization. Okay. Normalization is you arrange the data in such a manner that there is no repetition also. Excessive repetition is not there. But yet I am able to extract the information whenever required. Like I'm trying to say, I want to know the details of the department where Mr. Samit is working. Details of the department where Mr. Samit is working. So इस टेबल से मुझे पिक करना है समित का डिपार्टमेंट नंबर, इस डिपार्टमेंट नंबर को लेके मुझे इस डिपार्टमेंट फील्ड में जाना है, टेबल में जाना है, एंड फ्रॉम देयर आई हैव टू पिक द डिटेल्स ऑफ D02. I again repeat, my question is, get me the department details where Mr. Samit is working. Stuti, are you getting my point? We are trying to learn today how to work with multiple tables in SQL. Okay, till now we have been working with single table only. Now we start working with two tables. Actually, you can work with more tables at one point of time, but we learn how to work with two tables. The pattern remains same for the other tables also. Fine. So understand what question I'm trying to say. I'm trying to say, get me the department details. By department details, I mean everything about the department where Mr. Samit is working. As of now, I'm only showing you because मुझे ultimately आपको इसको करके दिखाना है कि वो कैसे मशीन इसमें से स्टार्ट करता है. So I've just taken department name, but imagine that there is department location, it has got number of people, manager ID or manager's name, manager's phone number. Okay, all this detail is there. So for Summit, I will get the detail as chemistry department and whatever else is there with me. Correct? So that means I need data from this table also and I need data from this table also. So how do I implement this kind of a thing in SQL? That's what we try to learn today. Okay. Now the query, technically, the way we have to write the query is very simple. Okay. So ultimately what you have to do in the paper, and you have to do it and learn and practice, that is very simple. But we have to understand the underlying process also. You might say, why, ma'am? Because that underlying process is also asked at times. Okay. So we have to understand how the machine will get that data for you. Okay. First most important thing is, this kind of a process can only be done when you have a common field. Okay. This kind of a process can only be done when you have a common field, because there has to be something connecting the two things, isn't it? If Summit I got from here, but I did not have this D02, then I wouldn't have been able to connect to this table. And if I wouldn't have been able to connect to this table, I wouldn't have been able to extract the data. Right? So there should be something wherein I should be able to connect. And that connect is primary key of one table. Here department table is, primary key of the department table is D01, D02, D03. And the foreign key is, this particular key is becoming as the foreign key in the teacher table. Tushita, patiently listen, beta. We are talking about working with SQL queries where we are using two tables at a time. I know your SQL concepts are not that clear, but whatever we do now today, at least that should be there in your mind when you revise the previous part. Okay?
Okay, ma'am.
Good. Thank you so much. So I am saying, look at this table. One has a teacher table. One is a department table. I'm saying that I want the department details of this fellow called as Samit. Department details. So if this table, I'm not showing you the whole field structure. I am saying that I've stored department name also in the department table. I've stored manager name. I've stored manager phone number, location. I've stored a number of people working in this department, all the details. Okay. So Samit, wherever he is working, I want the detail of that department. Samit, I'm going to pick from here. Take the department number from here. Go to the department table. Check out for this D02 and pick up the details from there. That is the process machine is going to do. Okay, for me. And that is how I'm going to write my query also. But how does the machine do it? Fine. In order to understand that, we have to understand a concept called as Cartesian product. Some of you in maths must have studied also. But still we do it once more, because everybody might not have done it. Okay. Now, using these two tables, the Cartesian product looks somewhat like this. Abhi kya hai? Now, what we have done is teacher name, and teacher's department number. When I want to refer to a particular field name with the table name, I also can write it like this. Teacher dot department number. Okay. I can write it like this. Fine. That is reference of the table, dot, and the field name. And why is it required here? I'm coming to that point later. So I have picked up the 3 things from the teacher table and 2 things from the department table. Okay. So it's like multiplication of the data by joining the fields also. Now multiplication of data means T01 Sumit, this particular data is multiplied or shown to you for all the departments of the department table. So you can see here this Sumit's information has been multiplied with department D01 also, D02 also, and D03 detail also. Can you see that? Then there's another person in the teacher table called as Alok. For this record Alok, I have joined it, I have multiplied it, whichever way you want to speak about that, with the 3 entries of the department table, D01, D02, and D03. Similarly, for the third person also, and similarly for the fourth person also in the teacher table. With all the records of the second table, my every record of the first table is kind of joined together. We use the term joined together. Multiplied also at times. Okay? Now, what am I getting in the first instance here? T01 Summit, D02. वहां से उठाया first record, D01 physics. Now, is this department correlated to this fellow, Summit? Is this record correlated to this fellow?
No.
No, it's not. Why? Because I can see for Summit, the department code is showing me D02, and here in the department table, the department code is D01. So this doesn't work for me. This is not Summit's data. Summit ka department ka data, this is not. How do I know that it is Summit's data? When this record matches, this information matches the department number from the department table. So I can easily make out here for Summit, this is matching. For Alok, this is matching. For Gurveen, this is matching. For Madhu, the other one is matching. Okay, all the highlighted ones are matching here. Can you see that? So machine also is actually doing it, you can say manual process. Se. Machine is doing it in a manual process. He takes up every record of the first table, joins it with all the records of the second table, then tries to find the matching data. And that matching data will come to me if I try to match my primary key of this table with the foreign key of the other table, because वहीं पे वो उसको match करेगा. Is it fine? This is what is called as my Cartesian product of the 2 tables. Is it okay? So Cartesian product will actually give me the whole entry, the whole data multiplied. Correct? But that is of no use for me. It's of no use for me. Because Cartesian product, you can see here, Samit is D02, Alok is D01, Gurveen is D01, Madhu is D03. When I multiply this data with the department data, I get something like this. This whole information. And if there are like more fields and more records, this is going to be a huge information, isn't it? So I am not going to be of, it's not going to be of any use. I cannot decipher anything out of that. So Cartesian product is this. But joining of the data is when I am going to ultimately ask him to match this information with this information. जहां जहां पे टीचर का डिपार्टमेंट कोड डिपार्टमेंट के डिपार्टमेंट कोड से इक्वल हो रहा है, pick up that particular information. Sukhmani, you're asking, so it won't match with respective entries. It is multiplying the data with all the entries and then ultimately matching it with the respective entries. It is. Hence, I'm going to get that Samit works in chemistry department because it is matching. D01 matching with D01 at this point. Hence, I know Alok is working in physics department. I will never say that Alok is working in chemistry department. Why? Because this is not matching. So the statement you have used is actually the correct one. It is going to match the corresponding entry. That is what we understand here. Am I clear? If you don't understand, please speak up. Anybody? Manuraj, you've joined little late. So give yourself time. You will get to understand what I'm talking about. Is it fine? Okay. What about others? In honor of Manuraj, I repeat the thing once more so that it's there in your mind. Okay. Let me go back. Manuraj, listen to what I'm trying to say. Okay. Till now in SQL, I've been working with one table always. There's one table, I would write queries based on one table. Okay. Now, today we learned that sometimes there's a need that I want to extract data from multiple tables. The question is why? I need to do so because at times we do not maintain the whole information of the second table in the first table. I can do that, but this will lead to a lot of redundancy. For example, the department details, if I try to store department details, if I try to store in the teacher table, like department name and number of people working in that department, the manager's name, the location, if I try to store every time the whole detail in the department table, why should I store it in the separate table if that is your question? The problem is if there are 20, 50, 100 people in the same department, you're repeating the details of the department 100 times unnecessarily. वो तो change नहीं हो रहा. If it is not changing, then why are you repeating it? Okay. So you should not repeat the data. That is my requirement. I don't want to repeat it. Correct? So that is why this concept of normalization was floated in the database environment, wherein they said, okay, keep the permanent kind of information at one place, then develop a primary key foreign key relationship, and whenever you need to correlate, match it and correlate it. Like for Samit, I need the details of my the details of his department. So from here, I'll pick up Samit and the department number, go and fetch for this department number in the department field and correspondingly get the data. ठीक है, उसका process क्या है? उसका process is that system first creates the Cartesian product, wherein for Samit, I multiply that with all the records of the department. You can see that here. Samit's data multiplied with or joined with the 3 entries of the department table. Okay, but ultimately I need to pick up that data where it is matching. You can see here D02 is matching with D02 jahan pe that data needs to be picked up. Otherwise it is of no use for me. Whole data I cannot cross check. Correct? Okay. So Cartesian product is this whole multiplication thing what I am showing it to you. But that is like a first stage or first step or basic prerequisite for my joining. Correct? Now, how do I do it in SQL? ये तो वो underline करेगा ही करेगा. But what query do I write in order to get my information? Okay. Number one, Cartesian product also I can see in front of me if I want to see performed on 2 tables, and this is how I do it. Select, get everything from teacher table. How do I write that? Teacher dot star. Get everything from teacher table, comma, get everything from department table, from first table, comma, second table, and he will show you the whole data. कौन सा data? Cartesian product वाला data, where everything is there. ठीक है? So resultant table, what you get when you are actually doing this Cartesian product, at that time, your resultant table will have the fields of the first table plus the fields of the second table, fields of the first table plus the fields of the second table. That is my number of columns. And if I take you back, the records will be records of the first table multiplied by the records of the second table. Why am I focusing on this information? Because this is asked in the exam. The exam says, consider a teacher table with degree as 3. Degree 3 means 3 columns. This is my first column. This is my first column, second column, third column. Hence, degree 3. DC. I said remember like DC current. Okay, so degree means columns. These are my columns. So teacher का degree 3 है, department का degree 2 है. So resultant Cartesian product का degree will be 3 plus 2, 5. Because all the fields I want. As simple as that. Okay. Now I talk about cardinality. That is number of rows. What are my number of rows? These are my number of rows. Number 1, number 2, number 3, and number 4. Similarly, 1, 2, 3. So, the resultant Cartesian product will have 4 into 3, 12 records. Okay, 5 fields and 12 records. So, the question which is being asked and will be definitely there in the class 12 boards exam is, table A has degree this and cardinality this. Table B has degree this and cardinality this. What is the degree and the cardinality of the Cartesian product? Okay, so for that, what you will do is, you will add up the fields and say that is the degree of the Cartesian product, and you will multiply the cardinality or the number of records as we call it, and that will be your cardinality of the Cartesian product. Okay? Am I clear with this? That is what we get here. So it is 4 records in the first table and 3 records. So 4 into 3, 12. So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 records and 1, 2, 3, 4, 5 fields. ठीक है? But हमें इतना data चाहिए ही नहीं. My need is not the Cartesian product. Cartesian product he has to do to get me the information. What is the information I need? I need the information wherever my teacher ka department number is tallying with the department ka department number. Okay. So this is the concept of join. So join operation combines tuples from both the tables. 2 or more tables technically. हम लोग 2 tables पढ़ रहे हैं. On specified conditions. What is specified condition? Teacher dot department number is equal to department dot department number. So ये अगर मैं minus कर दूँ the where clause, then it is a Cartesian product. If I put the where clause, it is my join. This is unlike the Cartesian product, which makes all possible combination of the tuples. सबको उठा के सबके साथ multiply कर देता है वो. Okay? In joins, so we say here we specify conditions on the related attributes of the 2 tables, which is generally the primary key of one and foreign key of the other. Now 99.9% times it will be primary matched to foreign key. But not 100%. So there could be situations where you match some other field. तुम्हारा requirement कुछ और है. ठीक है? So it might be that case also. But 99.9% times it will be a match of primary and foreign. So here we are matching department ka primary key with the teacher ka foreign key. Is it okay? Now, because when you are going to do it like this, yes, you can do that, Sakmani. Fine. So the moment you are talking about joins, you have to remember that the related data will be shown to me. So if I pick up the thing like this, it is simple to write. Select. Now here I have picked up everything. I want teachers se sab kuch, department se sab kuch. But generally in the questions, we will be talking about certain things. Like I said, I want the department details of Sumit. ठीक है? तो teacher का सारा detail मुझे नहीं चाहिए. I want department name and rest of the things of the department for Sumit. Correct? So in this case also, what we have to see is that this query gives me about everybody, Sumit and Madhu and all the teachers. Okay. So I can add additional condition here. I will write and wherever the name is Sumit. Okay. If I take you back, my answer to this query, which I wrote and showed you just now, was this. What would be this one? T01 Summit, D02, D02 Chemistry, T02 Alok, D01, D01 Physics, T03 Gurveen, D01, D01 Physics. Okay, and the last one also, this Madhu wala record, जो yellow highlighted है. But पहली बात तो I'm unnecessarily seeing department number twice. Second, मुझे teacher number भी नहीं चाहिए. I'm wanting to search only for Summit, तो मुझे इसको भी नहीं दिखाना. I technically want only chemistry as per this table, है ना? So I will also add in my condition, like where I wrote teacher dot teacher number and department dot department number should be equal, and T name should be Samit. So he will only pick up this data for you. I mean, this record. यहाँ पे तो I won't mentioned everything. This record for you and not everything else. Okay. So you can actually specify other conditions also if you want to. That is also possible with the join condition, but join condition is compulsory. Otherwise, you will get the Cartesian product and it will be a confusion altogether. Okay. I'll go a little further. Sometimes what happens is these table names are very big. Concept इतना ही है, अब इसमें हमें variations करने हैं, ठीक है? Teacher table name is very big, so I can use a alias name for the table names. Okay, so what I do is teacher is, I'm just referring to teacher as T. Let me just take you here. I can highlight it better in this places. Wait. हाँ, टीचर को रीनेम किया मैंने स्पेस देके, जैसे हम लोग 11th में किया था ना, फील्ड नेम को रीनेम करते थे, आई मीन फील्ड नेम को जस्ट एलियासिंग करते थे फॉर डिस्प्ले, है ना? सो सिमिलरली एज करके, बट एज की जरूरत नहीं है यहाँ पे, विद स्पेस ओनली हो जाएगा. सो टीचर इज टी एंड डिपार्टमेंट इज डी. सो आई कैन रेफर हियर, sorry, I've made one mistake. It should be t.tname. So instead of writing teacher.tname, I have to write, I can write, I mean t.tname. Fine. In the condition also, I don't have to write department, teacher.dep number is equal to department.dep number. I can just use the table name as T and D. Okay, so wherever I was writing teacher and department, I can write T and D if I rename it. But that's only applicable for this query. Next time onwards, again, you have to do it separately. It's not that ki ek baar kar diya, so it's applicable everywhere, nothing like that. Okay. Now, join can also be done by the method I showed you. Which method? This method. This kind of a query. Okay? But it can also be done by a join clause. जहाँ पे where लिखने की जरूरत नहीं पड़ेगी आपको. So you'll simply write select teacher dot star comma department dot star from first table name join second table name on condition. Instead of writing where clause, you can write it like this also. That is also correct. This is also correct. But in the exam, if they give you this kind of a query for correction or for output, so we should know that this is also applicable. This is also applicable. Okay. The next thing is, sometimes in the output, when I talk about the join output, my problem is that I will be getting duplication of the common field, na? Like it was showing me here. This one. Department number and department number दो बारी आ रहा है. Correct. Now I want everything. I don't want specifically T name. I want everything, but not the duplication of the department number. Why do I want it twice? I don't want that. So for that, there is another category of join which is called as natural join. Same join operation, same he'll match primary key foreign key automatically. वो भी देने की जरूरत नहीं है. And in the output will not show me the repeated field. So makes your life simple. Okay. Select star. I can easily say star because common field अब नहीं है. Otherwise it gives a redundancy error that you're asking me to display D number twice, जो कि similar है. So this doesn't work when the field name is same, primary key or foreign key का. But when you do a natural join, then you can write this. So your query becomes very, very simple. Select star, that is both the tables में से सब कुछ उठाओ from teacher and natural join करो department के साथ, remove the duplicate field, perform the foreign key and primary key का match and get me the data. So it makes life very, very simple. Okay. Other than natural join, whenever I'm using the equal to symbol, like we used it here, I mean this symbol equal to, or I've used it with a where clause here, or I've used it here without using aliasing. So whenever I'm using the match with equal to, I call that to be as equijoin. Whenever I use other comparison operators, I call it a non-equijoin. And natural join we have just now done. Okay. And this is another slide where I'm trying to specify that you can give additional condition also. Like I said, and T name is equal to Sumit. Like I wanted only Sumit ka data. I don't want everybody's data. So I can give that too. Okay. That is the concept of how I work with my multiple tables. What is Cartesian product? What is join? What's the advantage of join over Cartesian product? Cartesian सब कुछ उठा लेता है. Join में it only picks up the common data where the common thing is matching up. Okay. Now, the issue is, I don't know how much you understood, but the point is that this needs to be practiced a lot, because when the question is going to come in the exam, it is not going to specify that you have to use group by or having or join or nahi, या simple query है, double query है, multiple tables में से उठाना है, कुछ नहीं बताएगा वो, right? So next week when we have a Friday off or Saturday off, we need to practice questions now. Fine. So I just request you this whole week, go through how much you can, and then next weekend we'll have double class and we will practice the questions. Okay, the thing is going to finish also. We will meet next week now. Thank you for joining. Goodbye.
Thank you.
Thank you, beta. Bye-bye. And during the week, you can definitely come and meet me in the school hours also for any doubts.